A new car may start life with pencil and paper. But there are almost 5 years of hard development between the designer's imaginative sketches and the end result driving on our roads. It takes skill, effort and money to produce a vehicle made up of more than 15,000 individual parts, all of which have to be designed, developed, tested and manufactured. The very latest that automotive engineering can provide in an elegant, efficient and aerodynamic shape. To satisfy not just today's fashion and cost-conscious tastes, but those years hence. Car design has come a long way since Henry Ford first put the world on wheels. In engineering terms, his famous Ford Model T was so brilliantly simple that anyone who could ride a bicycle could drive one. During the 19 years it was produced, the basic design never changed. Its bare essentials approach suited the needs and tastes of the buyers of that period. But it was a far cry from the sophistication of today's modern counterparts. Combining human skills and up-to-the-minute technology, today's engineers must be continually refining their creation to meet demands for more quality, more performance, more comfort and reliability, while taking into account stiff competition from other manufacturers, present and anticipated safety requirements, and the fact that the new car must be produced efficiently, not as a one-off, but in thousands every day. So it's not just a case of drawing a pretty shape. The outline sketches of those working in the design studio may be exploratory, but they are influenced by hard engineering practice. All car design is a compromise, a need to create the best possible relationship between the exterior size and shape and the interior space available for mechanical parts, passengers and luggage.
There we are then, fellas. They're the principal facts and figures for the Model X2. Are there any questions?
Yes, Roy, could you tell
It all begins with a series of detailed paper studies aimed at identifying the most competitive product for a particular segment of the market.
Just one, Roy. I'm not quite clear in my mind whether the luggage volume takes into account the rear speakers or not.
Good question, Terry. It does not.
It does not.
A combination of knowledge gained from previous models,
grill, or would you prefer to have a separate grill?
comparisons of competitors' cars, and the results of extensive market research.
Well, I like to look for the looks of the car and also a little bit of power on the price.
The new design must appeal to the widest possible audience.
A few questions.
Will it take long?
From this, the product planners prepare a features list, defining cost and performance objectives for every aspect of the proposed vehicle.
From the outside, it's got to be aesthetically pleasing.
It must cater for a diversity of tastes and pocketbooks, even the different shapes and sizes of those using it.
Let's go and have a look at the rear end and find out whether there's a possibility without screwing up the aerodynamics and the luggage volume and maybe even the spare tire arrangement. I don't know yet whether there are any.
So car design is an exacting discipline.
Okay, Tony, this is the drawing. As I told you, we've moved the steering wheel down by about 8 millimetres, but unfortunately that's lowered the rim and brought it close to the driver's leg. So we're going to do a mannequin check to find out that we've still got enough leg clearance. So if you can hold the heel point.
Heel point's on.
I'll set the back angle in at 24 degrees. Yes, we've got the clearance there. I would say we've got to pull the mannequin back, I would think 20 millimetres.
Right, 20 millimetres, we'll go in at that.
Fine.
And today's designers make substantial use of the computer to record all the subtle changes made while refining the concept. Already, design engineers will be looking at the suitability of different mechanical parts, engines, gearboxes, etc. The desire to incorporate the latest developments, balanced by the need to produce a vehicle within an acceptable purchase price.
More or less the same as with the other.
And many techniques are used in the process of constant review and modification. For example, full-size exterior drawings are outlined in photographic tape. It allows possible changes to be assessed quickly.
There might still be enough room there for the driving lamp.
Yeah, we will find out. We might start with the best appearance first, and then we will find what the result will be.
I think this line ties it in more with the rest of our car lines, which is always a good thing.
Yeah, this looks much better already, I
think
think.
it's quite attractive.
So why not go this direction?
And while some in the design department work on the exterior shape, others will be concentrating on suggestions for the interior, assessing each new idea on the grounds of function, cost, and appeal. The designer's imagination, always tempered by the knowledge of the proven strengths of tried and tested components already in use on the road.
Hi, Richard.
Hello.
How are you getting on with these door speakers?
Okay, actually, I'm just moving them about in the door frame.
But they're quite low at the moment. Maybe on the next set of sketches you can...
It takes constant liaison between those involved to ensure that all the items of individual development will neatly dovetail into the overall design.
When we come down here, I want this to be nice and tight on the model here, I'll show you. We've got a very good condition here, and I want it held down to here with this component as far back as possible.
Even at this early stage, aerodynamic testing will be underway, using a variety of scale models in fiberglass and clay. When an instrument cluster is updated, it won't be merely a question of appearance, but whether it's more efficient, more reliable, and more easily read in all driving conditions.
That's also going to have circuit implications on the back as well.
Now, the other question is whether to have a central speedo or to have it offset on one side like this. Now, whilst I appreciate the appearance of this, I think we'll have to live with that one because of the cost savings involved.
Yes, and complexity is very important.
It takes millions of pounds to design and develop a new car. So even the updating of an established part has to be achieved within a budget.
It may give a totally different appearance to the wheelhead there.
Yeah, okay, we'll do that. Mark, this is the only possible location for the air inlet chamber.
From the customer's point of view, durability and ease of maintenance are important considerations. An efficient power unit is a basic requirement. But when the customer lifts the bonnet, he or she will expect it to be easily accessible and attractive to the eye.
That's good. Softer there will match the rest of the mirror much better.
And we only have to pay the investment of this part. We don't have a completely new one. So
good, that saves a lot of money. The investment for this part is about, what, $30,000?
To protect its identity, at this stage, the proposed design will be known only by a code name. And about 3.5 years before this model, known as DE1, is to be publicly announced, one design will be recommended for further development. By now, the first of as many as 8 full-size models in clay will have taken shape to help the designers, engineers, and senior management make sure the overall proportions are correct. Working like sculptors, the craftsmen will mold the clay into the right shape, translating the ideas of the designer into full-size 3-dimensional form for the first time. And the results are so lifelike that any outsider could be forgiven for trying to get into them. Each clay model is built up on a wood or metal framework, with a layer of hard polystyrene helping to add substance to the exterior shape prior to the clay covering. A thin piece of paint-covered plastic film helps bring the clay to life and complete the picture. Smoothed over the surface by hand, it can be easily replaced with a different color if necessary. Like these seats, a fiberglass version may also be made as part of the assessment program. So, working together, the designers and engineers have progressed from the huge amounts of paperwork and ideas to a life-size form. The character of the new car, outside and in, is now beginning to take shape. In the case of the dashboard area, a coat of water-based paint adds life to the textured finish achieved on the clay. And these clay models have to be absolutely accurate to allow the shape to be recorded by a computer-controlled device called a scan mill. Like the stylus of a hi-fi record player, a touch-sensitive probe travels across the surface, translating the shape of each part into a digital measurement. This data is fed into the computer network, adding to the growing library of information on every aspect of the new car available to all engineers working on the project. The computer provides the immediate link that coordinates the design program, from initial concept through to shop floor. It allows designers to modify a design using a graphic display, to turn a plan drawing into a moving three-dimensional shape, and if a design change is needed, to consider an alternative quickly. Here, a design engineer uses the data to display the scanned outlines of a clay door panel. A closer look reveals imperfections to the outer edge of the door lining not visible to the naked eye. Using a light pen, the draftsman smooths out these imperfections. Once satisfied, this data too will be fed to the master computer. The same data may also be translated into detailed drawings of the car, using an automatic drafting machine, seen from different perspectives and in various scales to enable others to study the implications. Computer-aided design and manufacture, or CAD/CAM, is now a major tool in car production, and data logged during the car's design and development will form an essential stepping-off point for those who must engineer the machinery and plant to build it. Color is an important element of the car's appeal. The interior, seating and floor coverings must complement the exterior paint finishes.
I think to go with the red body colour, we'll have to introduce a colour similar to this.
Numerous combinations must be offered, each planned in detail.
The lacquer red, which is a much darker tone.
Okay. Actually, this is a much nicer colour for that upmarket car. Perhaps we could introduce one of these colours. Yeah?
Yes.
And then again, we've got to decide whether we're going to put it into the warp or the weft. If we put it in the warp, it's going to be taking out a light yarn. If we put it into the weft, we'll take out a dark yarn. So the fabric's either going to go lighter or darker.
In the early stages, fashion magazines are a useful source of colour ideas. Even actual materials will be studied and adapted. And not just for appearance, but wear characteristics. Car trim must look good, even in the face of years of rough handling. Colour and texture also add to the illusion that this is the real thing. When a mock-up for a proposed instrument panel and interior layout is displayed on a wooden jig called a buck. Here, the ergonomics of the design are under scrutiny, the relationship of driving position to controls. If his performance is not to be impaired, the driver must be able to see and reach the instrument panel controls, steering wheel, pedals, and handbrake with ease. And this will be taken into account before the design is sanctioned. Equally strict criteria govern the development of the car's engine. Long before road testing, the hand-built power units will have gone through an exhaustive program of bench testing in the controlled environment of an engine test cell. It takes 4 or 5 hours to prepare the engine for a program that can last for days or weeks. A battery of tests covering spark and ignition efficiency, economy, vibration, durability and performance at all speeds and all temperatures. Here in the run-up, a spark plug fails, so preparation is all important. A crucial stage takes place here in Ford's own wind tunnel, the most advanced of its kind in Europe. Here, wind speeds in excess of 270 kilometers per hour can be generated to prove the aerodynamics of a design. Smoke-laden air passed over the proposed shape shows whether it offers a low drag outline or whether it generates turbulence. The outline should penetrate the air cleanly, not shove it aside. A shape that does this, allowing the air to break away smoothly at the tail end, will use less fuel by causing less air resistance as it moves. This is a good aerodynamic shape, and it could take thousands of hours of testing minor modifications to achieve results as successful as these. Once all the elements of model DE1 in digital form are logged on the computer, this data package will be analysed and double-checked at Ford's Engineering Centre at Dearborn, and the combined power of computers in Britain, Germany and America effectively speeding up the development process, until the data can be translated into metal for the first time. These moulds will cast the dies for the first prototypes of the new model. Made in a softer metal than production dies, they're only hard enough to form about 70 panels. The early pressings are all hand-finished, some parts handmade, and the development program is still flexible enough to allow for minor alterations. A specially prepared jig helps the prototype take shape. And every weld, every surface will be checked. This will be the yardstick for the production car and must conform to all the data, including the results of the continuing program of safety testing. This is just one of many prototypes doomed to be catapulted at exactly 50 kilometers an hour straight into a solid concrete wall. Weeks of preparations are over in seconds. Each test vehicle is packed with electronic devices called accelerometers that measure any shift in one direction. The analysis based on hundreds of measurements taken before and again after the crash. And the full effects on the car are recorded by an impressive array of still and motion picture cameras. To meet the safety requirements, the front crumple zone must protect the passenger compartment in a violent impact. Similarly, in a rear collision, the passenger compartment has to remain sound. And the petrol tank too must be protected. Elsewhere, other components are meeting their fate. For every hour spent on design, 100 are spent on examining, analyzing, perfecting. Using computer-controlled programs, laboratories become torture chambers for the merciless testing of component parts. With the aid of the computer, the effects of torsional stress on a door are studied. Modifications made, and after an exhaustive manual test program, the new structure given the seal of approval. Using these computer techniques, whole body structures can be examined for possible weaknesses. In the search for a solution, batteries of electronic sensors can be attached to components in a vehicle under test,
Then we're going to attach our TCA load cell.
with portable recording equipment logging the results of road performance.
Approaching the end of the moving surface.
This data can also provide a basis for laboratory testing of components. Meanwhile, other parts are receiving their baptism of fire on one of Ford's specially constructed European proving grounds. Here, over a 6-kilometre route, a car can drive down a country lane, over uneven and loose surfaces, through corrosive saltwater troughs, or give components a hammering at high speed on a major highway. Suspension, for example, may appear mechanically simple, but its operation and its effect on passenger and driver comfort are complex. Thousands of minor modifications may be necessary following road and laboratory testing before the engineers are satisfied. Hour after hour, day after day, the testing continues, stressing every component to the limit and beyond. Using special test facilities, 6 years of hard road driving can be condensed into just 3 months. Today's production car has its own onboard computer, of course. Really a family of micros, this central processing unit is continually measuring the load on the engine and controlling the ignition for maximum fuel economy under all driving conditions and all climates. Where the sizzling temperature of 46 degrees Celsius is as tough on the man as it is on the machine. The heat and dust of the Arizona desert. Taking the cooling and lubrication systems to the limits of probable use. Each test car covering in a day more miles than most people drive in a week, and at speeds in excess of 200 kilometers an hour. And as if that wasn't trial enough, after every 60 kilometers of non-stop high-speed driving, it's into the heat-soak shed. There, at over 50 degrees Celsius, another 40 minutes with the engine running without the cooling benefit of air pushed through the grille. Then it's back for another grueling session on the dirt track, on and on into the failing light. This pattern continues even on the other side of the world. This is 225 miles inside the Arctic Circle, not far from the Soviet border, northern Finland. With barely 3 hours of available light each day, testing for man and machine begins before dawn. It's 40 degrees below freezing. Left out all night, the car's engine must fire in 6 seconds on choke. Over the first hurdle, ahead lies another day of ride and handling trials on ice and snow, looking in particular at ABS, the car's anti-lock braking system. When an attempt is made to induce a skid and spin while braking, the car has to maintain maximum steerability. The system under test is similar to that used on aircraft. When the wheel is about to lock, a microprocessor instructs a valve in the brake unit to release the brake. Gathering speed, a second valve is instructed to pump the brakes on again. And the constant cycle of brakes on, brakes off, many times a second, won't allow the tyre to lose its grip on the road surface. Even with a hands-off approach, when the brakes are applied, the car has to remain under perfect control. As the car approaches the end of its development period, amongst the many appraising the new model, triple world champion Jackie Stewart.
Getting that strong wind-up, that strong self-centre feel. That has certainly diminished.
Isn't it nice?
Most drivers would be unaware of subtle refinements in suspension and steering. But Stewart's development experience in Grand Prix racing makes him an ideal judge of ride and handling at high speed or when avoiding obstacles.
The car has a solid feel about it, and that's a good start. But the lane change is another matter. It's a very unsettling maneuver for a car. Now, I'm able to go through this lane change in this car at about 120 miles an hour entering speed, which is very quick. The car is very precise, and that's a nice feeling for the driver. We want to be sure that our car gives the driver, he or she, the opportunity of not only avoiding the obstacle that suddenly steps out or moves into the path of the vehicle, but also that you can recover from that maneuver positively, regaining control and staying away from trouble. At the end of the day, I have to drive the car to the ultimate limit of its ability to find the true character and personality of the car. And if I don't drive it to that ultimate limit, I will never know if the car's got some very bad habits or not.
Finally, after all the modifications and fine-tuning have taken place, it's time for the heads of the many departments involved to pass judgment. This management appraisal is the final seal of approval, and a new car is committed to production. The tooling and dies prepared, the training program begins. Individually, the members of the workforce become accustomed to the techniques of assembling the new model. And so do the robots. One month later, the first of the thousands that will be completed daily nears the end of the production line. And a new car is born. In all, it could have taken up to 5 years to reach this point. But even now, the product planners, the designers, and the research engineers are hard at work developing new designs, new materials, and new components for its replacement years hence.
Use that on a fuel injection system in the future.
There'll be more glass area on the 92 model. Is that going to give us problems?
The Granada drag coefficient, 0.33, is a good starting point.
Take another look at these gear shift speeds. Both the road and lab tests have shown up serious deficiencies in torque output at low revs.
3.5 now, let's try the kick down.
The low friction pistons have given us two benefits. Firstly, less parasitic loss.
See, approximately 2.5, and the wind noise is still quite low.
I need to get PP sign-off on BE13 now. Job 1 is only 6 months off.
Well, the modifications have been wind tunnel tested and the figures are okay. I think the new clay has cured it.
Okay, let's have a look.